Yeah, very good afternoon to one and all. So today we are going to start this subject called Advanced Computational Methods in Power System. So this subject, Advanced Computational Methods in Power System, it is a continuation of your power system analysis or computer methods in power system, what you have studied in your UG. So in some universities, we have studied like computational methods in power system, or in some universities you study like computer methods in power system, or power system analysis, or advanced power system analysis. This is just a continuation of this subject, power system analysis or computer methods in power system. So as in a PG level, we are going to analyze, because already you studied this in your UG level, this computational methods in power system. But as in the PG level, so we are going to study extra in the sense we are going to analyze more on the particular topic. So that is what we are going to do with this subject. So as the name uh, name comes, like computational methods, uh, actually here in power system there are many complex networks. Complex networks. Say for example, if you want to do the load flow analysis, okay, for a 3-bus system or 2-bus system, easily you can analyze. Like a few problems also you might have solved in your UG, like a 2-bus system, 3-bus system, like that. But if you go for more bus systems, say for example, practically speaking, there will be not only 2-bus system existing in your system. Say for example, in power system, there will be not only 2-bus system or 3-bus system. Why we have taken that 2-bus system, 3-bus system? Because for solving or for understanding the problem, it is very easy for we to analyze that 2-bus system or 3-bus system. So more than that, it will be time consuming, and also it will make the problem complex, that you know. But a real power system, okay, if you take the real power system, that will be of many buses, okay. So normally more than 40 buses, 50 buses, more than that, okay. So for analyzing that, those bus system is one of the challenging task and complex task, okay. So if you start solving that problem with your pen and paper, say for example, you're analyzing the load flow analysis for 40 bus system. Okay, if you start with pen and paper, I think you need to solve more than 24 hours. Okay, it will take more than that also. You need to solve like that. It will be a never-ending problem. Like the complexities will come. Okay, more. So that's why we are going for some computer methods. Computer method in the sense some analysis tools like MATLAB or PSCAT, ETAP. So these are the some of the analysis tools, so that your problem can be easily solved. Say for example, in MATLAB, okay, so predefined bus systems are there. Okay, IEEE bus systems are there, 39 bus system. So 118 bus system, predefined bus systems are there. So for testing purpose, we can take that 39 bus system, and we can easily solve. But practically speaking, there will be not 39 bus system or 180 bus system. That is the standard bus system recommended by IEEE. But practically speaking, it will be of more than that. And if you solve that particular problem, the complexity of the system also goes like anything. So for solving that only, we are going for, and also framing the data. Say for example, we are taking the all the bus system all over the state, or total India, all over the India. So how many buses? There will be more than like infinite bus system. Okay, so if you take in one city itself, it is more than okay, 100 bus system or 200 bus system. And if you take over the state, it may comes more bus system. and solving that problem will be, I think, it is a very complex problem, maybe in this universe or world. Okay, so what we are doing is we are making certain assumptions. We are making certain assumptions that this is constant. Okay, so load is not varying. Okay, so like that we are making certain assumptions and try to attempt that problem or try to solve that problem at least. Okay, certain assumptions we are going to make in this subject, and we are going to attempt the problem. So that is the, because if you take almost all problems, say for example economic load dispatch problem, if you take, so I think you might have solved with a 2 bus system, 3 bus system, like that. Maximum 3 bus system you might have solved. So more than that, okay, you can solve up to 5 bus system by pen and paper, but more than that, it is very complex, and that too certain assumptions we are doing. And same thing for unit commitment problem also. So unique commitment problem is also committing the generating units for a particular 24 hours period of the time, uh, is a very complex problem. But what we are doing is we are making the certain assumption, that is load is not varying. Okay, so voltage we are maintaining the constant, power we are maintaining the constant. Like that, we are making certain assumptions and trying to attempt that problem. Okay, attempt that problem that already you might have studied in your undergraduate subjects. So here, exactly what we are doing is we are going to mathematically model. So almost if you take all the your postgraduate studies, that is like research studies. Okay, so it is not like a, yeah, undergraduate, like you need to solve some problems, study the concept solving problems, like that. So here in the postgraduate level, you need to mathematically model the problem. You need to understand what is happening in that problem. So where, say for example, what is the inputs you are giving, what is the output there. So how to analyze the model. We are concentrating more on analysis and mathematical model of the particular thing what you have studied in your undergraduate subject. So here also, so we are going to mathematically model the load flow studies of the power system and distribution networks and fault analysis. Coming to the fault analysis, so fault analysis also, it is one of the toughest problem. Okay, so like say for example, the distance for the fault analysis also matters. And say for example, if the fault is simply like a line to ground fault, that is can be easily solved. And if you take the substation, there also they will do this fault analysis. They will analyze the fault. They will consider that fault is happened in this particular feeder. So what will be the change in the voltage? What will be the change in the power, reactive power? How to solve that? How to attempt that fault? Okay, suppose this kind of fault happens. How to attempt that fault? What are the things we need to corrective actions that have to be taken? So like that, many things are there in the fault analysis. So here also we are going to analyze that fault also with some mathematical modeling. Next thing is that we are determining the power flows with the load flow models. Okay, so there are some load flow models. Okay, so for formulating this load flow models, say for example, if you take this unit number 1, so basic power system components and their representation. So here the unit number 1, we are going to concentrate on a single line diagram, how to frame the single line diagram. So what is significance of per unit representation? Already you might have studied the per unit analysis, per unit, how to calculate the per unit. So what is the advantages of calculating this per unit? Like that you studied in your undergraduate. So here, what is the significance we are studying? What are the physical parameters? Okay, so how to tune with that unit per unit representation, that we are going to see here. Next is a single line diagram of the power system, typical single line diagram. that already you have studied in your power systems 1 and 2. So there a little bit we are going to analyze that single line diagram also. And this concept of incidence matrix, then A and A bar matrix, and also their limitations, and representation of generator, transmission lines, and transformer. Next is a primitive and network matrix, that also we are going to analyze. Next is a formulation of Ybus matrix, and meanwhile Ybus, if you analyze means, so you can also analyze the Zbus matrix, impedance matrix. Okay, so that also you can analyze. Then by formation of Ybus matrix by inspection methods and what algorithm you need to follow for the formation of Ybus matrix, basic Ybus matrix formation, and as well as Ybus formation by using inception method, that also we are going to analyze. Next is what are the merits and demerits, what is the purpose of solving this Ybus matrix. See, in almost all load flow analysis problems, so the first step is calculate the Ybus matrix. Say, for example, if you are taking 2-bus system or 3-bus system, the first step what you need to do is to calculate the Ybus matrix or Zbus matrix. So that is what basics we are going to study in our first unit. Then applications. So next is the unit number 2. So unit number 2 is load flow analysis. So load flow analysis, a little bit you might have studied. So in your computer methods in fast system analysis, like Gauss-Seidel method. Next is Newton-Raphson method, and another one is Fast Decoupled method. Here we are. What we are doing is we are analyzing more on this. So here what we are doing is first static load flow equations. We are going to formulate the static load flow equations. So from that, any doubts about? Okay, so doubts at the last. I will give the time for clarify your doubts. So that doubts you can we can clarify at the last. Okay, so here the unit number 2. We are going to solve the Gauss-Seidel method. Then load flow algorithm. The algorithm is there. So after this algorithm, whatever the limitations in the Gauss-Seidel method, so what we are doing is we are going to overcome with the Newton-Raphson method. And here in Newton-Raphson method also some merits are there, demerits are there, limitations are there. So that Newton-Raphson method limitations, that we are going to overcome with the fast decoupled method. So this fast decoupled method is a combination of this Gauss-Seidel method and Newton-Raphson method. So what are the limitations are there in your Gauss-Seidel method, and as well as limitations are the Newton-Raphson method. So we are going to rectify in this fast decoupled method. So we are going to frame this algorithm and solve the few problems in this load flow equations, that is analysis in a Gauss-Seidel method and Newton-Raphson method and fast decoupled method. And here also every algorithm has its own merits and as well as limitation. That also next is application. So it is being applied. Next is AC and DC load flow solution. So that also we are going to discuss in the second unit. Next, coming to the third unit, and here distribution system load flow analysis. So okay, so here load flow methods, vector based load flow method, then backward forward sweep method, current injection method. Okay, so here a little bit of distribution side. So distribution side, how we are going to do the load flow analysis, especially with the renewable energy resources. So what are the techniques used for this load flow studies? Even in PV and wind energy system or combination of this. So there, how we are going to analyze the load flow, that we are going to study in detail on this third unit. Okay, so coming to the fourth unit, so little bit you might have come across this short circuit studies already in your UGs. So short circuit studies, in that short circuit studies, so what is the formation of a Zbus matrix? Next step by step approach. Okay, so addition of branch. Okay, so in formation of Zbus matrix, so one branch we are adding. So how to frame the like a matrix for that, and if you are adding a link, how to make that matrix for that we are going to analyze. Next, what are the assumptions made in the short circuit analysis? So applications. So any short circuit happens in the line or in the distribution system. So how to overcome that? So what we are doing is we are priorly we are analyzing this short circuit studies, and what are the corrective actions has to be taken. So that also we are going to discuss in this fourth unit. So next is modification of Zbus elements. So after this, we are going to solve some problems also for on this in the short circuit studies. So coming to the fifth unit, symmetrical sequence components. So here we are going to analyze, discuss the significance of symmetrical components. Okay, symmetrical components and its approximations. Next, formation of this Zbus primitive matrix. Okay, so and what are the various types of faults? Okay, with respect to that symmetrical components and as well as some unsymmetrical components. But here only symmetrical sequence components only given in the problem. Okay, so that also there. And here formation of Zbus by step algorithm. That same thing is repeating here, and the derivation relevant to this like IPF, next EPF and EI. So for triple line to ground fault and ground to line to ground fault. So like that we are going to analyze symmetrical sequence components only. We are going to analyze for in this unit number 5. Okay, so textbooks given like Stag. Stag is one of the good book like for studying and understanding computer method in power system analysis by Stag. Okay, so that is the standard book. Publisher is Tata McGraw Group. Next book is Computer Techniques in Power System Analysis by Chatterjee. Okay, so that also from Tata McGraw Hill, like third edition they have given. So then you can go for a Haddy-Sadat power system analysis by Haddy-Sadat. So these are the reference books, Haddy-Sadat. And another one book they have given like Watson, okay, computer modeling of electrical power systems. So and a little bit you can take so advanced power system analysis by Nagarath and Kothari also you can take. There also some in some simplified format they will be given. Okay, so if you take that Nagarath and Kothari, it is a combination of these two books, Stag and Haddy-Sadat. They what they did is they copied from this Stag and Haddy-Sadat book. That book you can easily follow. Nagarath and modern power system analysis by Nagarath and Kothari. That book also you can follow. But apart from this, you can solve problems also. So, like a few problems solved in Stag book and as well as Haddy-Sadat. So that also you can refer, and in Kothari book also it is there. Okay, so I think problems are also we need to solve with the problems and as well as theory. But understand first you have to understand the theory properly, like the derivation, the mathematical modeling. That if you understand, then the problem is very easy for you to solve. Say for example, the first unit also problem like formation of Ybus, Zbus matrix by inception method and algorithm. By that algorithm, we need to solve load flow analysis also theory, algorithm and problem. Next, load flow methods. I think here no problem. Third unit, no problem. Only theory and that methods we need to study. Next, coming to fourth unit, the problems are there. Okay, after the short circuit studies, we need to attempt with a problem. And here, fifth unit also theory plus problem. So, I think approximately 4 units we need to solve theory as well as the problem. So, for a better understanding of this subject.